I'm tired, boss. I'm tired, and you know what? I think JavaScript is tired too. Mitigating denial of service vulnerability from unrecoverable stack space exhaustion for React, Next.js, and APM users. APM being application performance management users. So what we're talking about here today, guys, is a remote DOS that affects Node.js/V8 based on implementations of try-catch handlers and async hooks. Who uses async hooks, may you ask? React server components, so anywhere that does server-side rendering, therefore Next.js, other frameworks that use async local storage, and then basically every APM tool, so Datadog, New Relic, Dynatrace, etc., which all make use of async hook.create hook packages. The main issue here, guys, is there is a problem in computing when you use recursive functions where recursion allows us to make arbitrary stack frame. If you're not aware, a stack frame is basically a region of memory that contains the local variables for a given function. So in this example here, we have the function factorial. Factorial can be written as a recursive function, recursive just meaning that we call the function itself. And so as we're calling factorial 5, 4, 3, 2, 1, every time we call into a new instance of factorial, unless we're doing tail call recursion, which is not the default case in V8, we're going to allocate more memory to run the factorial function on the stack. We're going to allocate more RAM to host the variables that factorial needs. And this will grow and grow and grow and grow until eventually we've allocated so much stack space that we exceed the maximum allowed amount of stack space for that process. That is called a stack overflow in some scenarios. Now, the issue here is, normally in JavaScript, if you make a very, very recursive function, you will get a range error. The maximum call stack size is exceeded, and you can use a very simple try catch to block that from happening, right? You can use that. You could say, hey man, you've gone too recursive. You're too in the recurse, and then it'll just go into your except block, right? Well, the problem is if you are using an async hook system and the function is async that underneath is using the recursion, it will just kill your process with an exit code 7 instead of allowing the try catch blocks to process the error. And what actually is happening is it skips the uncaught exception handlers and just kills the process entirely. So imagine, for example, you have a Next.js API route that calls handler, and handler is an async function that does something recursive, right? It processes nested data, and processing nested data is literally going to recursively map into itself until it gets to the bottom of some array, right? You have arrays, and it's going to go into the data until the data is no longer an array, and you transform the data and return it, right? And the example data here is a 50,000 levels deep JSON array, right? Which could be arbitrary user data. This could be data that the user is just giving to the server. So, in a normal non-async function that is not vulnerable to this, there is some max amount of recursion depth that the node process is aware of. And if you exceed that per call, you'll just throw a range error and you'll try accept out, right? The issue that's going on here is really, really interesting. So in the really technical deep dive, the way that async hook works is anything async in JavaScript, if you're not aware, is a promise, right? You don't actually get the data back from an async call, you get a promise, and then the underlying async runtime resolves the promise. The way it actually works under the hood is this async hook fires to track the async context, right? Now, what actually goes on underneath the hood is the async hook gets wrapped in a try-catch scope where the catch mode is a K fatal, okay? So when you do try accepts, right, there are multiple nested layers of potentially try accept statements. And when an async hook function gets ran, it wraps it in this K fatal. K fatal means literally if anything happens, it is an unrecoverable error. You need to exit it immediately. And the problem is, if you go deeper into the call stack here, in a recursive function that makes use of this async hook, even if you register internal try-catch handlers, it is still outer wrapped with the K fatal, which means that when you eventually get your stack overflow error, which should throw a range error, what you're actually getting is a K fatal, which tells the process, hey, we don't know what to do about this. It's dangerous. We got to kill it. You got to get out of there. Okay. It's no bueno. What I found super interesting about this, by the way, is that, so this is an issue within Node.js. Node.js is a runtime for JavaScript, and inside of that runtime, it uses the V8 engine to execute the JavaScript itself, right? What's interesting is that V8 doesn't treat this as a security issue. You may be wondering why. Crashing is very bad. Well, V8 is primarily a JavaScript engine developed for browsers, right? And browsers, being a client-side piece of software, have a much different security model than a server-side piece of software, right? It is not a security vulnerability for your browser to crash. You will know that if you've used the internet ever in the last 2 years, where I feel like every site that I go to in some form or fashion, Twitch, crashes my browser. And so because of this is an issue that V8 is not aware of, but it's just not part of their threat model, right? It's not part of their threat boundaries they've established. If you are able to crash V8 in a non-exploitable way, they really don't care. Well, I guess crashing it from a Stack Overflow perspective, right? Or stack exhaustion, we're using overloaded terms here. And so as a result, Node.js, which depends on V8, kind of inherited this issue. And it's super interesting too that even ECMAScript, the specification that defines JavaScript, specifies that you should use proper tail call recursion so you don't have these giant stack frames. You should reuse stack frames as often as possible in recursive cases. But this is not even implemented by most JavaScript engines, usually, including V8. They usually just kind of make a new one the way that C would make a recursive call happen. Also, stack space exhaustion is not specified behavior. So again, we're going back to the ECMAScript here. The maximum call stack size exceeded error is not part of the ECMAScript specification. The specification does not impose any limit, assuming infinite stack space. Imposing a limit and throwing an error is simply behavior that JavaScript engines implement on a best effort basis. Building a security model on top of an undocumented feature isn't guaranteed to work consistently, so it would be unreliable. Yeah, and this is what's interesting, right? Like, even though it's not in the spec, the stack is going to be limited by the kernel, right? There's like U limits that are put in place for processes. At the end of the day, it should be on either the spec or the implementer to have a stack size allocation limit. And it does exist, obviously, right? Like we have the range error that deals with this. The problem is just that the exception handler for async hooks was interwoven into the exception handler for stack overflows, right? So because of this, when you finally do resolve that error, it's going to be like, hey, this is a K fatal. I can't handle this, kill the process, and then suddenly you're in a DOS scenario. So yeah, man, it's pretty weird. What was the fix for this? Literally in the try catch scope inside of Node, what they did is they say, hey man, if we catch an exception, let's go into the exception. And if this exception is the result of a Stack Overflow error, all we have to do is rethrow the exception at the lower level and we will just keep going down the catch frame, right? Otherwise, if it's not a Stack Overflow, treat it as a K fatal and kill the exception. Now, the patches are out for the following versions here. So if you're the developer of an application that uses async hooks as well as can ingest nested JSON objects, highly recommend you go and patch because you could be up for a DOS scenario. So interesting stuff, guys. The world of processing arbitrary user data, even in a sandboxed language like JavaScript, it's really hard. It's really, really difficult. And to answer your question, would Rust have fixed this? No, not at all. Infinite recursion can still occur in Rust, right? Rust is actually notorious for being more apt to crash your process. If you're not aware, one of the major cloud outages that happened in the last few months was the result of a .unwrap. .unwrap is the process of opening the box that you will call that an option comes inside. An option is either a sum type or a none type. And if you unwrap an option, you crash the process. So Rust is, as a security choice, more likely to kill a process than to let something happen. Which is, I guess, similar to V8's model, but in this case, at least, this didn't, it wouldn't have fixed it. There's no real reason to use Rust here. But anyway, guys, that's it for now. Thanks for watching. I appreciate it. If you like this video, do me a favor, hit that like button, and then go check out this other video that I think you will also like just as much. See you over there. Take care. Goodbye.